Right. So, do we have any big questions from? Oh, 2.4 is not open. From our homeworks yet? Like any big issue? We had a couple things. I had a couple students find a couple errors, which you probably never realized if you did your homework after they came and talked to me. Because once somebody tells me about an error and I fix it, you won't experience that error. So that's the good thing about like when your peers do come let you know. So where were we in 2.4?
We were at like the bottom.
These, the 60 calories per dip, those things, or were we further than that? We did those. Yeah, because then I think we were talking about what if we had like $9 or something like that. Like I was making up other problems. And we talked about rupees for a second and the different exchange rates. Yeah, so let's just flip straight to the back. We'll finish up this back real quick. So 2.4, you have these from last week. Guys, this goes back to your organization piece. If you cannot keep a set of notes organized, you need to change your system. So, oh, I need to drag the other thing up to the TV. My bad. Hopefully we get to 2.5, and then we can discuss that start slide. So you're going to go to Spain. Kind of jealous. And when you ask for the exchange rate, the bank hands you a table. Now, most banks would probably not actually hand you a table because they know that most Americans are going to then complain. But we are not complainers. We're smart people that enjoy a challenge. So we see this table, and we want to know how many euros a lot of countries use the euro. We want to know how many euros I'm going to receive for X dollars. So the amount of dollars that I have is my input. That's my independent variable. So if you really want to have some good notes taken, label that X is your independent variable. And you can abbreviate that if you'd like. If you can remember that that means independent variable.
Can you put IV?
You probably want a little bit more than that because like IV, you might get confused if it's an intravenous line or something. Do you have your notes, bud? Why? So meet with me at AOR Extensions. We're going to do a little organization check, okay? This is not a punishment type thing, but if you can't keep notes for a week, that's an issue. Library, printer. Actually, hold up. I might have my copy that I can give you. Unless I've given them all away. So you guys should be able to go ahead and compute this on your own.
Did we get new notes?
Not yet today. No, these are last week's. You should have had these. This is why we're going to meet and figure out your organization. Black and white printer in the library. So, then y, if x is your independent variable, what type of variable is the y? Andrew?
The Y is how many euros you have per American.
Yeah, but if we call x independent, what would y then? If you're not independent, you are dependent. So y is going to depend on x. So we know that our statement is going to be y will equal some relationship with the x value. Now, how do I figure out this some relationship? And now, we have a letter that we use to represent that. And we have a fancy name that takes on. Do you remember that fancy name?
I don't know the name, but I think I know what to do.
It starts with a C. Anybody? It was actually the title of one of our lessons. Jaslyn? It's the constant of proportionality. And we can use a variety of things to put here. But most often, you will see this as y equals mx. M, if you want to remind yourself, is the constant of proportionality. And I always abbreviate proportionality. It's just a real long word to write out. Yeah.
Can I do the question? I have the answer.
Okay, so how did you figure it out? I don't want just the answer.
I can tell you that too.
Okay, go ahead.
So I was looking at the table and I'm like, what's the simplest way to do it? And you could, I saw the second one, which is 100 to 75, and that seems the most simple because I'm looking at all the other ones. And so $100, that's, so like that's a whole number in percents, which it's 100%. And euros, I could 1, and 75 divided by 100 is 0.75, because you want to know for every $1 how many euros do you get. So for every $1, it's 75 cents of euros. That's 0.75 euros.
So let's back this up. I understand what you're saying, but we want to make sure that mathematically it all makes sense. So there's going to be a division that has to happen. We know that. But we want to talk about any time we're trying to find that m. What would always work? Now, I agree. This is going to be our easier point. But especially, what if we had a situation that didn't have that easier point? I want a way that I can find m that will always work for me. Samantha, do you have an idea?
Can you do x divided by y?
Ooh, close. If we look at this equation right here, how would we get m by itself? What would we need to remove, Ellie?
You divide by x.
Yeah, we would divide by x.
Can I also tell you what I got and how I got it?
Yeah, so hang on just a second. So if we divide by x on one side, I have to do it on the other side. This x divided by x, any number divided by itself is just 1, and it wipes itself out. So what we actually find out here is that the m, anytime you want to solve for that m value, your constant of proportionality, it's really, I'm going to go ahead and give you guys the precise formula. It's delta y over delta x. Now, I've heard Mr. Cabilo talking to you guys about delta, so I think you already know it. Andrew, what's delta mean?
The difference between.
Difference or change. So we're really looking at the change in a y value over the change in the x value. Now, sometimes you'll see this just written as m equals y over x. That is because in a proportional relationship, we always have that 0, 0 point. So the change in y and the change in x can relate back to 0, 0. You want to be careful. Once we get beyond proportional relationships, this will still work. It just won't necessarily be a proportional relationship. So we'll get there. Right now, what we're working with is proportional relationships. But know that this formula is going to carry on for the whole year. This is a really important formula. So if I was you, I'd highlight it, circle it, put stars around it, draw like pretty birds and sunshine. I don't know. Whatever you do to point it out on your notes. So now, Ellie, you said that you have an answer, that you solved this.
Okay, so I did, because I saw the 100 to 75, and I divided, but I wanted to double check. So I did 37.50 divided by 50.
So let's verify. My euros are my y values, so that column is my y's. My dollars are my x values, so this column is my x's. I need my y over my x. So you do 37.50 over your 50, or I don't really like decimal values that much. So I would actually grab this one. I do my 75 over my 100, because it's the y value, your dependent, divided by your independent. That's the reason I identified that this is our independent. It's your dependent divided by your independent, and this comes out to be 0.75. So in the end, our equation that we would want to write is going to be y will equal 0.75 times x. Or if you really want, you could write E, the amount of euros, will be 0.75 times D, the amount of dollars. But we know that X represents my dollars. Y represents my euros. So we can leave it right like this. Now, this exchange rate is not current. Just to let you guys know. This was the exchange rate years ago. It's constantly changing. So this is not the current exchange rate. Not that long ago, the dollar and the euro were very close to each other. Like the exchange rate was almost 1-1.
What is the now? It's 1 euro is 1.09 US.
Yeah, so it's very close. 1.09 compared to 1. That's really close. So, in this situation, can you stop flipping the pen? Because you can't keep track of your notes for 2 days. Let alone, I know you're not focusing on me when you're flipping your pen. I've shot you the eyeballs a couple times. Sorry that I'm having to verbally take care of it now. In this situation, what's different about what they're asking me?
USD
Ellie?
dollars are Y and the euros are X.
Now my dollars are the Y value, and my euros are the X value. Is that going to change anything?
Yes.
Because so read this situation. Think about the problem we just solved. The problem we just solved was you are going to Spain. You are in America with your dollars. You need to get euros. Now you're coming back. Now you have a pocket full of euros. And you need to trade them back to the bank for dollars. So now the dollars that we get depend on what? Well, not only the exchange rate, but how many euros I have, right? So now my dollars have become my dependent variable, and my euros is my independent variable. So now my variables have kind of traded places, which is dependent and which is independent. Jeremiah?
I had a question.
Yeah.
So if I bring like $20 to Spain, it would be the same value?
No, you'd exchange it for euros. Now you're going to get the same value, but it will be a different amount of money.
So would it be more or less?
It's the same value, but it will be a different amount of, depending on what kind of money you're exchanging it for, the amount of euros or amount of rupees or amount of whatever currency you're dealing with, it'll be the same value, but it'll be a different amount. So it's like taking $1 and exchanging it for dimes. Do you still have $1 worth of money?
Yeah.
Do you still have your dollar bill?
Yeah. Oh, no.
No. Dollars to euros, same exact thing, just a different exchange rate that can change. Our exchange rate, dimes, nickels, quarters, that's all constant. It stays the same. The exchange rate country to country does not stay the same.
Wait, so am I allowed to use money here to there?
Yeah. You can take dollars there and use them if they accept dollars at the store. You could use euros here if the store accepts euros, which most places don't. Other countries are better at accepting dollars than we are at accepting other currency. Because think about like how many people come to America, and think of how many Americans go travel in other countries. Like a lot of people take dollars to other countries and they're just like, okay, fine, whatever.
It'd be crazy.
Then they just take it to the bank and exchange it. But if we accepted all of the currencies from all of the countries that came here, a lot of different countries come here. So it's all like whatever they decide to do.
Yeah, 'cause
Real quick, Jeremiah.
So if you were to go over the border with like 50 US dollars, and then you go over there and get however many rupees, and then you come back, would you still have the same amount of dollars if you didn't
If the
spend it?
exchange rate has stayed the same while you were traveling, yes. So imagine this. I have $50. I go to Spain. I stop at the bank and I exchange it into euros. I get $37.50. I end up using my credit card the whole time. I don't spend any of my euros. I come back. I go to the bank. I hand them my $37.50 euros, and they give me back $50.
what are the prices the same?
Yes, but they'll be in euros. So, like, the same is a dangerous question. Manasa?
Then couldn't you like technically make money?
You could.
Like you take
It won't
like $50 to some place, and then you wait for the exchange rate to like
Yes.
go up. So when you come back, you have like $60.
Yes.
Wow.
You could, but it's very hard to predict because you could also lose money the same exact way as you were just talking about potentially making money. Andrew?
And can I explain a little bit about this because I know what I did wrong. The answer that I got up here, I know it's going to be for here.
How do you know that you're going to have that answer from up there for this question down
I
here?
looked at the wrong way of constant proportionality and divided them wrong in the whole
If the independent and the dependent change places, then when I set up my y equals mx, now instead of my y being the euros, my y is my dollars. So when I set up my formula to solve my m here, that m will be y divided by x, or delta y over delta x if you want to be precise. You guys should be writing this. Now if I use these same values, it's not 75 over 100. It's 100 over 75.
That's what I did.
Which gets 1.3 repeating forever.
1 and a third. I got that up.
So when you're coming back, we could say the amount of dollars that you will receive will be 1.3 repeating times the amount of euros that you trade in. Or we could still just say y equals 1.3 repeating times x. Either of those are the exact same formula.
That would suck though, because you would never know how much things cost.
Yeah, in some places, so my brother travels to Europe a lot because his company is based out of Switzerland. Some places, they put both prices on there. Like, if places know that they have a lot of travelers coming through, they will have the euro price, but then they'll also have, like, how many dollars that equates to. So in your head, you can think through, is this a good deal or not? Like, because if something said, it costs 37 euros, but I'm like, well, shoot, I don't know the exchange rate. Is that, like, I don't know how to, in my head, think, is this something I want to pay? If they tell me it costs 37 euros / $50, like, they give me both, then I can think, oh, dollars. I know the value of dollars. It makes it easier. That's a dollar. So Mr. Shurg says whenever our phones go off in our meeting. Is that, do you know who it is?
No, it was just a random number.
Can I answer?
There was some fake number that kept calling us, and it was like trying to get your credit card information because apparently like something was wrong with the IRS. And we kept calling them back with all our different.
It was probably a scam, just by the way.
And we kept calling back with like different numbers, and like we would just call back in these random voices, and they didn't know who it was.
So if you hadn't ignored your call, I would have answered it and like told them not to call back and put you on the do not call. If you like, if a telemarketer or a company calls you, and this is the trick where most of the time they hang up really fast. If you tell them you must not call me again, you must put me on your do not call list, they legally cannot call you again. But if they hang up before you say that, they can call you back again. So that's why a lot of places will hang up really quick. All right, we got to keep moving on. I'm sorry. I know we got a lot of stories. The rest of this, we're just going to breeze through so then we can jump into our next lesson. So this setup right here, hey guys, bring it back. We talked about this last week just a little bit. So the other way that you can solve these problems without using the equation that we've been using this whole time is to set up a proportion. So we know that in an average adult, I'm going to zoom in on this just so we can read this. In an average adult, we know that for every 5 pounds of body weight that you have, approximately 3 pounds of it is water. So when we, and like some of you guys might start wrestling or whatever else, when wrestlers are really trying to lose weight, they would try to sweat out their water weight. Or when they're trying to gain weight to make a certain weight class, they'll try to drink just a ton of water because your water amount in your body does fluctuate. But approximately for every 5 pounds that you weigh, 3 pounds of it is water. So if for a week I don't drink very much water and I work out a ton and I sweat a ton, I can drop weight by getting rid of a lot of that water, but it's really unhealthy. My buddy, because I'm telling that story, I got to tell the story that goes with that. My buddy did just that to get to the weight he needed for his wrestling to go to states. He weighed in, was at the weight he needed to be at. Then later that day, passed out because of dehydration, and then he could not wrestle in his state wrestling match because he had passed out at the tournament. So you can only get yourself to a certain point of dehydration before it gets real dangerous. So he just had to live with that, like it was his own mistake. That, like, well, he could have wrestled at states, but he got himself too dehydrated. I actually saw him this weekend when we were out camping. So that's our ratio. That's our comparison. 3 pounds of water weight to 5 total pounds. Or we could say 2 pounds of not water weight to 3 pounds of water weight. Or we could say 2 pounds of not water weight to 5 pounds of total weight. Like, we could set this up a few different ways, but we set it up right here. Get off of the highlighter. We set it up water to total. So on top, we set up our water. On bottom, we set up our total. So on top right here, my unknown amount is going to be how much water. My known amount is what's my body weight. So let's say we have a 188-pound adult male. That's fairly average for adult males. If he weighs 188 pounds, then we know that corresponds to the 5 pounds of total weight. Here's the other part about some of this problem solving. Before you touch a calculator, before you do any of this, what could you say about this W? What do we know about that W compared to 188?
It's 3 parts of 188.
Well, it's 3/5 of 188, but we know it's got to be less, right? If this numerator is less than this denominator and they're set up in a proportion, I'm trying to make you guys, some of you are turning in tests with answers that you should be able to figure out don't make sense. If you get a number for this answer that is bigger, you should realize that doesn't make sense. So when we set this up, we can solve this a few different ways. So I want you guys over to the right of here to show the other way that we could solve this. We could just multiply by 188 because we want to get rid of the division that's happening. If there's division to the variable, I can multiply and get rid of it. Because really, this is 188 over 1, 188 on top and bottom cancel each other out. But the other way to do it, and this is what a lot of you have been like begging to do for a while, cross multiply. So we take your cross products, and guys, if you're going to write this out, you need to write out all of the work. Write out the 3 times 188. Write out that we do the 5 times W, which that one, it's pretty easy to write that out. But the 3 times the 188 is what most people try to skip, and they just write the answer. I really encourage you to write out that we're multiplying those two values. I'm now going to switch color to be like a neutral color. 3 times 188, 300 plus 240 plus 24, 5. 564.
Yeah.
Does anybody have questions on what I've done up to here?
Oh, it's 560.
Usually, if you turn or multiply by 5, you end up with a one digit of a 5 or a 0. So you could go decimal. Oh, right, use decimal for answers.
So here's where we get 564 equals 5W. Does anybody have questions on how I got here? I took the one set of cross products that I colored blue equal to the other set of cross products that we have colored red. Then we do the math that I can do. I can do that multiplication. I can't really do this, but I can just write it as 5W. I don't have to write the multiplication dot. Any questions?
Wait.
There's multiple ways. It all depends on your brain. I'm just showing you another way.
Wait, so you did 3 times 188 divide?
I did not divide yet.
Oh, no.
All I did was set up the cross products equal to each other. All I did was what this tells me to do.
564.
3 times 188.
Oh.
The work goes vertically. You should be able to look back up to figure out where did it come from. So then, to get the W by itself, somebody not Ellie tell me what to do. Because Ellie's on it. She's got it. She's rock star on this. Dom?
Divide by W, or divide by 5.
I need to get the W by itself, so we get rid of the 5. We divide by 5. And when I do that, I'm going to get 112.8 pounds.
Oh, wow, that's a lot of pounds of water.
So if I weigh 188, which sadly I'm getting close to, if I weigh 188, 112.8 pounds of my weight is water.
Wow.
You have to think about how much water is in your blood, in your cells. Like everything has water in it, so you got to think of how much weight that actually makes up. Dom?
Could you just do like 188 divided by 5 and then
Times 3? Yeah.
Oh, I can do that.
Which is actually what we did. So Dom just asked, couldn't we have done 188 divided by 5 times 3? We did. We just did it in a different order.
188.
188 divided by 5 times 3.
Oh, yeah, so perfect.
It's what we did. Like, we just did it in a different order. So, last thing we'll probably do from these notes. if the ratio of goalies to total players is 2 to 30, which is fairly standard for soccer, there's not very many goalies, and the league has 915 total players, how many goalies are there? Set this up as a proportion. If I was you, I'd be setting up goalies over the total players. Question or answer?
Question. Do you know the average weight for a 12-year-old?
You can look it up. There's tables of all that stuff. But that's a really hard question to answer because everyone hits their growth spurts at different times.
I know what an 11-year-old is. 11-year-old is like 80 to 90.
But that's still really hard to answer because everybody hits their growth spurts at different times.
I'm never gonna hit mine.
You could actually find that out with X-rays. So you have these things inside of you called your growth plates, and they can see how much growing you have left to do.
I need to go now.
Yeah.
skeleton is only 10 years old.
Mm. So, who can walk me through this? Okay. With apprehension, I'll say, Dom, talk us through what you did.
Okay, well, what I did was I put 2 over 30, which is there's 2 goalies for every 30 players. So then I did,
Hey guys.
Then I did 915 divided by 30 to find out about how many, to get what number I should multiply 2 by.
What'd you get from there?
I got 30.5.
And then you doubled it?
Yeah, and then I just multiplied 2 by 30.5 and I got 61. So I got 61 goalies for 915 players in the league.
So, Dom has realized that if I take these corresponding denominators and just say, well, how do I go from here to here? Because what you're really doing, Dom, this 30.5 is the multiplication factor that takes us from one side to the other side. So, he just multiplies by 30.5 on top and gets his 61. Now, the other way that we can do this is if I use my cross multiplication method. What would be my cross products that would be equal to each other? Jennifer, do you know if I'm setting up cross multiplication? What, like, so the 2, what would the 2 multiply with?
Who's Jennifer?
I got so confused, but I didn't want to say anything.
Yeah, I was like,
Then did one.
what?
Your sister.
Sorry, that's so the longer I teach, the more siblings I see, and the worse this gets. This is why I'm so sad right now. I'm the youngest in my family, right? So I had older brother Brad, who I kind of look like, older sister Abby, and my teachers. Like, we have a small high school where they all knew everybody. They'd be like, Brad, and they like couldn't ever remember my name. They could remember Brad, they could remember Abby, but getting to Micah was always so hard. So sorry, Ashley.
She looks just like her sister.
Yeah. Thank you. That's what my brain just did. So what would the 2 multiply by?
2 and 950.
Yeah, because my top left goes to my bottom right. We have to be diagonal. So we'd have 2 times the 915. Then, well, this is kind of obvious, but my 30 then multiplies by my G because that's all that's left. That 2 times 915, 1830. I'm going to switch to a neutral color, though. Hey, gentlemen, this is your last opportunity to chill out before I rearrange you, and then you don't get to choose your seats ever again. Write this down. Or do you already have it done in a different way? Okay. And then, and it will serve you benefit if you just get used to solving these equations right now, because then that chapter is going to be really easy for you. We just divide by 30 on both sides, and we get the same 61 that we already knew about. Any questions, concerns, comments, queries, quandaries? Pretty much the same thing as everything else I've been listening. Just fun keywords. have confidence that you guys could solve this. Now, the one thing that I will caution you with solving those proportional relationships is be careful what they actually ask you for. Sometimes they'll give you like a part and then ask you to set up a problem involving a part and a whole. So read carefully. Close reading is vital here. I'm really sorry about that. As my brain gets older and I see more and more students, those names are just imprinted in my brain.
I think she looks more like
I have two brothers.
Oh, so
They look identical.
Really? Are they close in age or not very?
I think one's in 4th grade, one's in 2nd grade.
So, maps and scale drawing. So I go back to my start slide for today.
Yay!
Who has ever looked at a real paper map? A real paper, not Google, not on the internet, a paper map. Okay, this is more than I thought. So, if you are curious to look at a paper map and you haven't, I have Ohio maps right back here. Actually, that's county map. County. So on every map, and there's a map posted in the hallway too, right out there. On every map, you're gonna get a key, and your key down here on this map is right here. What sort of stuff is in the key? I should have paired with Pedigree to talk about this lesson. Elena, what kind of stuff is in the key?
So like what symbols mean?
What symbols mean? So like what a dotted road versus a solid road versus like a blue road, which is not a road, it's a river. Sam, what else is in the key?
Like what a capital looks like in the city.
Yeah, all the other so there's actually on the Ohio map, there's really funny my wallet's out in my car. So if you haven't seen my wallet, I took an Ohio map and I made it into a wallet. One of the funniest things about this map, I'm from Coshocton County originally, which is right here. And there's just this little deer, and then there's like a little plane, and there's like all these little symbols on here that all mean different things. So this little deer, there's various around the Ohio map, there's just little pictures of deer. It literally means a wildlife area. But one of the most important things in the key, and what I'm trying to get us to, is what looks something like this. Or on this map, it literally is right here, and it says miles and kilometers. And then right below it, it says scale, 1 inch equals approximately 11 miles. Now, why do they say approximately? Anish, why do they say approximately?
They don't always know like what it's exact.
Yeah, and if you're measuring an inch on this map compared to how far that would actually be in real life, sure, it's close to 11 miles, but your inch, if I ask you to measure an inch, and you to measure an inch, and you to measure an inch, I bet you they all won't be exactly the same length. So most keys will say approximately. If it's verbal, it'll say approximately. Or it'll just show you the picture, and it's up to you to measure. So I might measure, okay, I want to go from way up here to way down here. I can measure how far that is, and then compare it over to this chunk to set up and be able to solve how far the actual distance is. Jeremiah, question?
Isn't an inch on the U.S. map 100 miles?
It depends on how big of a map you're looking at. The size of the map will determine the size of the scale. So if I have an Ohio map that's the size of the wall, 1 inch will be less miles actually because the map got bigger. The smaller the map is, the more miles every inch would have to cover. Does that make sense? As the map gets smaller, your scale has to get bigger. Manos?
Doesn't the scale thing not really make sense if you like want to travel and find distance? Because
That makes perfect sense. It's just hard because you don't travel in straight lines.
yeah, because you like go a whole bunch.
But so if I draw on my map like that, I literally drive like this, then I drive like that, and I could just like add up all those. I could measure each little bit and add them all up, and then make my conversion.
If
I remember, like, this is going to make me sound old, even though you guys know I'm not that old. I remember doing this with my mom. I think they use it as an activity, but we were planning our summer vacation. We literally, with a highlighter on the map, highlighted our route to get down to Virginia Beach, measured it out. I really, now that I look back on it, I'm like, oh, Mom and Dad were just teaching me math. But they had me measure it out, write down each measurement that I took, and then add them all up and figure out how many miles. And then I made some prediction about how long it would take us, and we were pretty darn close. And this was back before Google Maps. I mean, MapQuest existed, but it wasn't that great yet.
Dinosaur era.
I know, gosh, I'm from paper maps and before TomTom.
MapQuest, I've heard of it, but what is it?
It's literally Google Maps, just not as good. All right, we got to move on. Sorry, we got to move on. I only got like 5 minutes left. So, maps and scale drawings are essentially the same thing. A map is just a scale drawing. If a map isn't a scale drawing, it's as big as the actual thing. So if you have a map the size of Ohio, that doesn't make any sense. It would be pointless. So maps are scale drawings. So where it says and, I really should just say like map/scale drawings. So anytime you have something that is representing something of another size, so, like cartoons, anime, those sorts of things, when you actually read them, when it's on paper, I see some perked interest, that's a scale drawing, unless it absolutely doesn't look right. Because if you make the head really big and the body really small, you've goofed up your scale drawing. But if everything looks how it's supposed to, it's a scale drawing. So, this boat, let's say we want to draw a picture of a boat. I'm not going to draw a picture of the boat, the actual size of the boat. So instead, I choose a scale. I say that every inch in my drawing will equal 15 foot in the actual. Now, does that mean that my drawing is only 1 inch?
No.
No, that just means that if it's an inch, it's 15 feet. What if it's less than an inch?
Less than 1.
It's less than 15 feet. More than an inch? More than 15. So we could then set up our ratio in the 3 different ways. We obviously see the colon, we could say to the verbal, or we can set this up either inches on top, feet on bottom, or feet on top, inches on bottom. It doesn't matter which. The only difference it'll make is you're solving, like the method you use to solve may be different depending on which way you set this up. Either of these is fine as long as you make the other ratio set up the same. So here's our example. The golden plovers migrate from Nova Scotia to South America. I think it's like a type of bird or something like that.
Yeah, it's a plover.
What is up with plovers?
I don't know. So if we know that 1 inch equals 400 miles, that's the scale given to us on there. Do I know anything else?
No. Oh, wait.
Yeah?
You know the route they're going.
Well, I know the route. We're going to say that since they fly, they can fly in a straight line.
You know where Jacksonville is in Orlando?
Sean, will you do me a giant favor
No.
and measure that line?
Yeah.
So what you want to write down on your paper is your 1 inch to 400 miles. Sean is nice enough back there measuring this distance.
What is it?
0.8.
Whoa, that looks like a bird.
What does?
Well, Mr. Hudson just drew. If you tilt your head sideways, that's how I learned how to draw birds in the 2nd grade. A giant.
So it's a bracket. It's a fancy bracket.
No, that's a bird.
So since I know I measured the inches of my drawing, where should that 8/10 go? Ellie?
It goes in the top or wherever you put the 1 inch.
Yeah, wherever you put your inches, that's where our measured inches go. Then we don't know our denominator, but I sure can solve it. Now here's what's really easy about a lot of scale factors. If they relate to a 1, what happens when I cross multiply my unknown distance with 1?
It's because they just create this.
I just get d. So I get 1 times d, the unknown distance, equal to 400 times 8/10.
doesn't make sense.
Why?
Because when you do 400 times 0.8, whatever you get, then you just divide by 1.
We don't divide by anything.
Yeah.
Because dividing by 1 wouldn't do anything. So that's why I said it's really nice when a scale factor involves the 1 inch or 1 of whatever. So this is actually not just a scale factor, it's a unit rate. Because it's 400 miles per 1 inch, that's a unit rate. So because it's a unit rate, I don't have any division to do. All I do is the multiplication, and I'm done. So we get, I believe, 320.
320 confirmed. Miles.
Now, since my scale factor uses the 1 inch, the other thing that I want you guys to see here, I could have just said, how many inches do I have? Multiply by your scale factor. Because it uses the 1 inch. The only reason I can do that is because it uses the 1 inch. The only lesson we have left is the problem-solving lesson. So plan that tomorrow we will finish this lesson and do the problem-solving because that one should be kind of quicker.
Wait, so it's
2-4 is due at midnight tonight. 2-5 I'll make live and that'll be due like midnight Wednesday probably. All right, thank you guys. Have a great day.